This is Algebra 2, Chapter 1, Section 4, in which we will be solving absolute value equations. Well, to do that, we need to remind ourselves what absolute value is. The absolute value of a number is how far it is away from zero on a number line. It's a measure of distance, and distance is never negative. So the absolute value of something cannot be negative. We're going to spend a little time evaluating a couple of absolute value type expressions, such as this one, 8.4 minus the absolute value of 2n plus 5, if we know that n is negative 7.5. Well, first off, we substitute in what we know for n, and then we use our order of operations, clean up the inside of the grouping symbol. 2 times negative 7.5 is negative 15. Negative 15 plus 5 is negative 10. The absolute value of negative 10 is positive 10. So then 8.4 minus 10 is negative 1.6. All we did was use the order of operations and just plugged and chugged. So I'm going to ask you to pause your video at this point and try out this problem, absolute value of 4x plus 3 minus 3.5, if you know what x is. So you plugged in your negative 2, did the arithmetic, cleaned up, and you should have gotten to 1.5. So onward we go to absolute value equations, and when we're going to solve an absolute value equation, we use what I just made this thing up a few years back, I call it the Stuff-Blah theorem. It sounds funny, so you're more likely to remember it when we talk about doing the stuffs and the blahs, and it'll stick in your mind a little better usually. So the Stuff-Blah theorem says if I have the absolute value of some stuff, whatever's inside, equal to something over here, blah, then the stuff on the inside is either equal to blah or it will be equal to the opposite of blah. Okay, put another way, whatever's inside here, let's say this is a 12 on the right, whatever's inside here either has to be 12, because the absolute value of 12 is 12, or it would have to be a negative 12, because the absolute value of negative 12 is also 12. So when you have a setup like this, you have an absolute value equation, you're going to have to split it into two problems. You're going to have to split it out into two problems and solve each one. So we have the absolute value of x plus 12 is equal to 9. We're going to split that out into two separate problems. X plus 12 is equal to 9, or x plus 12 is equal to negative 9. Well, from here we know how to solve both of those equations. We're going to need to subtract 12. If we subtract 12 in the first case, we get negative 3. And if we subtract 12 in the second case, we get negative 21. So those are our two solutions to the problem. Once again, I'm going to ask you to pause here and solve this one. Absolute value of 2y plus 5 is equal to 9. Solve the problem, and then we'll check your answers. So hopefully you split that into two separate problems. You did a little arithmetic to move the 5 over and then dividing by 2 in both cases. And you should have gotten y equals 2 or y equals 7. And yes, you need to report both answers. Why is it giving me the blank screen again? There we go. Now, they like to try to throw a trick at you. They like to throw in having a negative value in the blah position just to try to trick you into doing things you don't need to do. If your blah piece is negative, that is to say if the stuff away from the absolute value is negative, then it's no solution. And they're really good at disguising that. Because right now it looks like your blah is a positive 2. But it's not, because this is in the way. To be in stuff blah, you need to have just an absolute value on one side, with nothing else with it. So I need to subtract this 8 out of my way. Subtracting 8 gets me to a negative 6. Now I've got absolute value of stuff equals a negative 6. Remember what absolute value is. It's positive. Or it's at least not negative. It might be 0, but it's at least not negative. So I have something that's not negative equals a negative number. Not this week. No solution. But notice how they disguised it. You have to get I shouldn't say stuff. You have to get the things that are with the absolute value out of the way. So we had to get rid of the 8. We have to get rid of this negative 2. We have to get it out of our way. It's multiplied, so we need to divide. We divide by negative 2, and now we've got absolute value of stuff equals negative 3. Nope, can't have that. No solution. Again, they disguised it. Let's tackle a more interesting case. Okay, we have variables all over the place. We have variables inside the absolute value. We have variables outside the absolute value. We've got just a general mess on our hands, but we can work with it. Our first thing we need to do is get the absolute value isolated. So we need to move this x over out of our way. We'll add x to both sides. And that gets us to 4x minus 4. Now we need to get rid of the 2. So we'll divide by 2. Dividing by 2 over here gives us 2x minus 2. Now we're down to where we can split it out. We're at absolute value of stuff equals blah. So let's split it into its two problems. X plus 1 equals 2x minus 2, or x plus 1 equals the opposite of 2x minus 2. And I'm just going to solve them one at a time to make life a little easier. This one, all we have to do is subtract the x over, and then add the 2, and we get x equals 3. That's one answer. One candidate, anyway. And then your other case, we need to distribute that negative first. Then we can subtract, or we'll add the 2x over and subtract the 1. Divide by 3 and we get x equals a third. That's another possibility. Now, we have to do something we haven't done yet. We have to check our answers because we may be telling dirty lies. Not intending to, but we could have bad information to work from. When you have variables in your blah, like we do here, you have to check it. When it's just a number over there, you can look at that number and see whether it's positive or negative. But we don't know whether 2x minus 2 is positive or negative. So we have to plug our answers back in and check. And I like to go back to the beginning of the problem because it makes life a little simpler for us. So we're going to plug in our 3 and do a little simplifying on this side. Thought it went hiding. X, or 4 there, and 3 times 3 is 9. So we get 5 is equal to 5, which is true. So that answer is good. Okay. What about in the other case? Let's plug in our 1/3 and see what happens. Well, we plugged in our 1/3, so we have 2 times 1 1/3. 2 times 1, and the absolute value of 1 1/3 is 2 2/3 minus 1/3 is equal to -3. No, it's not. 2 2/3 minus 1/3 is 2 1/3 equals -3. So this answer is false. And since one of the answers is false, we throw that one out, we're left with just x equals 3 as the correct answer. Okay. Be aware, you could have both answers be true, in which case you would give both answers. You could have one positive answer, one negative answer, or one true answer and one false answer, in which case you would only report the true answer. It could turn out that both answers are false, at which point you would say no solution. So it could be 2 answers, 1 answer, or no answers. Last thing we have to look at is they like to throw this at us in a word type thing. So we have a standard tennis racket, has a 100 square inch head. The area that you actually hit the ball with has an area of 100 square inches plus or minus 20 square inches. Our job is to write and solve an absolute value equation to determine the smallest possible size and the biggest possible size. Okay. I know you can look at it and say it's 100 plus 20 or 100 minus 20 to see the possible sizes. But notice what they ask for, and what we have to do is write and solve an equation. So, warning, if you do not write the equation, you will get it wrong. So our equation is of the form the accepted value minus the normal value is equal to the tolerance, the absolute value of it. So in this case, what's acceptable would be x minus the 100 square inches that's normal equals a tolerance of 20. Well, now we're in stuff blah, we can separate it. Add the 100, and we could get 120 square inches or 80 square inches. So the greatest possible size is 120, and the least possible size is 80 square inches. When they give you units in the problem, make sure you report units with part of your answer. Otherwise, I might think you've changed it to something else and be giving me square centimeters or something, and let's just stick with the units we have. So make sure if you have units, you report those. And as always, hopefully if you had questions along the way, you wrote those down. Bring them in, and we will see you in class.